Okay. On problem number 5, it says two cars are racing around a circular track. The red car is traveling in a lane that is 84 feet from the center. So that's this blue, 84 feet from the center. The blue car is traveling in a lane that is 89 feet. So that is the green I've drawn here. Both cars are traveling at 180 miles per hour. How much later in seconds will the blue car finish if they race one lap around the track? So the first thing I need to figure out is, well, how many feet did they actually travel? So the 84 one is the red car. So this is the red, and this is the blue car. So circumference is the distance around the circle. So you would want to do 2 times pi times the radius. Well, the radius for the red car was 84, and the radius for the blue car is 89. So when you type this in the calculator, 2 times pi times 84. Okay, the red car has gone 527.78, and it keeps 75, keeps going. The blue car, and that's how many feet. Okay, the blue car has gone 559.2034, keeps going, feet. Okay, and so it says up here that 60 miles an hour is 88 feet per second. So the question is, if both cars are traveling at 180 miles per hour, how much later in seconds will the blue car finish if they race one lap around? So these cars are going 180 miles per hour. So I took this 60 miles per hour and I multiplied it by 3 to get 180 miles per hour. So I would do the same thing with the 88 feet per second. I would need to multiply it by 3 to make this equivalent. So they're actually going 264 feet per second. So if this is how many feet they've gone, we want to divide both of those by 264. So when we do that, we get 1.999 seconds for the red car, 2.118 seconds, and it keeps repeating decimal for the blue car. And they're wanting us to round this to the nearest tenths. So this top number, this number would end up being 2.0 seconds. And this number would end up being 2.1 seconds. So if we want to know how much faster it's going, we would need to subtract those two. And so 2.1 minus 2.0 is going to get me 0.1 second. So in seconds, the blue car is going to be finished 0.1 of a second slower. Because it's traveling the outside of the track, which is more distance. Okay, so lateral surface area is just the area around the figure. It does not include the top and the bottom. So when we're taking lateral surface area, what we want to do is we want to consider the front of the figure, which is also going to be the same as the back of the figure. So the front and the back. So because we've got two things, the front and the back, and they're both 8 by 5s, we would come up with that calculation. We also have, so that's the front and the back, and we've got the two sides here. And this would have to be 7, and this would have to be 8. And we've got one in the front, and if you can imagine that there's one in the back of that as well. So we've got two sides that are in the lateral. And remember, when we do lateral area, we do not include the top or the bottom. So we're going to do this side, which is an 8 by 7. Okay, so 2 times 8 times 5 is getting me 80. And feet squared. $112 feet squared. Then we're going to want to add those two numbers together and get 192 feet squared. That's going to be my lateral surface area, 192 feet squared. And to get the volume of the box, right, volume is just length times width times height. And in this problem, we've got 5 times 7 times 8. And that's going to get you 280 feet. And we're talking about volume, so feet cubed. Okay. The company installs a rectangular septic tank 10 feet long by 5 feet wide by 6 feet deep. Calculate the capacity of the tank in gallons. It says you can use this conversion and round to the nearest gallon. So the first thing we want to do is calculate the volume. So 10 by 5 by 6. That's going to get us feet cubed. So we have 300 feet cubed. Okay, and then we've got, they want to know how many gallons that is, so we're going to need to do a conversion here. So I'm going to put my 1 foot cubed on the bottom and my 7.48 gallons on the top. Okay, so whenever I do this conversion, I'm going to do 300 times 7.48, and that's going to get me 2,244 gallons. Okay, and it says round to the nearest gallon is needed. We didn't end up having to round on this one, but we wouldn't have any decimal places. An automobile engine. In an automobile engine, the bore of a cylinder is its diameter. The stroke of the cylinder is the height swept by the piston. We want to find the swept volume of a cylinder with a bore of 3.68 inches and a stroke of 3.5 inches. Okay, so they told us in the problem that the diameter is the 3.68, which is the bore of the cylinder, and that the height is your stroke of 3.5 inches. So these are both in inches, so that's good. To find the volume of a cylinder, you do pi times the radius squared times the height. Okay, in our case, we're given the diameter. So to find the radius, we would need to do 3.68 divided by 2. You take your diameter and divide by 2. 3.68 divided by 2, this is going to be 1.84 inches. That's going to be my radius. So in my formula here, I would say pi times 1.84 squared times my height of 3.5, and that's going to get me 37.226. It keeps going. They do want us to round to the tenths place, I believe. So that's going to be 37.2 inches cubed. So my answer would be 37.2 inches cubed would be the volume of that cylinder. So it says write the angle in decimal degrees. So we've got 150 degrees, and this is how many minutes, and we could possibly have seconds here too, but we don't. So we've got 150 degrees and 51 minutes. Okay, so I know that my answer is going to be 150. This part's already done for me. This is in minutes, which is out of 60. So I would actually go 51 divided by 60. 51 divided by 60 is 0.85. Okay, and so this would be 0.85 here. Degrees. Still. Okay. During a wheel alignment, the camber on a certain car is measured to be 1 degree in 24 minutes. If the maximum acceptable camber for this car is 1.350, is the camber within the limit? Okay, so as before, we know we get the 1 from our 1 degree. To get the 24 minutes is a decimal, we would do 24 divided by 60. And 24 divided by 60 is 0.4. So what we have is 1.4. And it says if the maximum acceptable camber for this car is 1.35 degrees, it looks like if ours is 1.4, we would be over. So no, it is not within the limit. The price of 9 citrons and 4 fragrant wood apples is 96 units. The price of 4 citrons and 9 fragrant wood apples is 86 units. Find the price of a citron and the price of a wood apple. Okay, so we've got to kind of define some variables here. I'm going to let C equals a citron, and I'm going to let F be fragrant. Okay, so I have in the first formula 9C plus 4 fragrant wood apples. So these are fragrant. For F is equal to 96. The price of 4 citrons, so 4 plus 9 fragrant wood apples is 86 units. So what they're asking us to figure out is find the price of a citron and find the price of a wood apple. So we're trying to find the prices of these things whenever we solve this. So there's a couple of ways to work this problem. You could just do guess and check and figure it out. Mathematically, what we want to do is make something where when you add the rows together, they cancel out. So I'm thinking that I can, and it's legal to multiply by something. So I'm thinking I'm going to multiply the top row by 9. I'm going to switch these and make the top row be multiplied by -4. I picked that because this was a 4 here. Okay, so I made it be the opposite. And the bottom, I'm going to multiply by 9. I'm going to keep it the same. And once I do this, you'll see why. But -4 times 9 gives me -36C. -4 times, we've got to take -4 and multiply it by each thing. So -4 times 9 gave me -36C. -4 times F is going to give me -16 F. Okay, and then the last step on this top part would be -4 times 96. And -4 times 96 gives me -384. Okay, then I'm going to come and do the same thing with this 9. I'm going to multiply the 9 times the 4. That's going to give me +36C. 9 times 9 going to give me +81F. 9 times 86, that's going to get me 774. Now, I can add these rows. What's going to happen if I've got -36 and +36? Well, those are going to cancel out. -16, these two cancel out. -16F plus 81F is going to get me 65F. Okay, -384 plus 774 is 390. Once we get it to here, we can divide by 65 on both sides. And so we find out the cost of the fragrant apples when we do 390 divided by 65. We find out that those fragrant apples end up being $6. So once we know that, we can plug that back into any one of our formulas. I'm just going to pick the top formula. So 9 times C, we still don't know what C is, 4, but we do know that the F here can turn into 6 because they're $6 a piece, equals 96. So 9C plus 24 equals 96. Subtract 24 from both sides of your equal sign. That's going to leave me with 9C is equal to 96 minus 24, which is 72. Then we're going to divide both sides by 9, and our citron is going to cost 72 divided by 9, which is 8. So our citron is $8 and our apples $6. The pressure loss, F, in pounds per square inch of a hose is given by this formula. Q is the flow rate in hundreds of gallons per minute of water through the hose. If the pressure loss is 42.2 pounds per square inch, what is the flow rate? Okay, so basically what we know is we've got this formula, F is equal to 2Q squared plus Q. And we know that F is 42.2 because it tells us here, 2Q squared plus Q. And to solve these quadratic problems, what you're going to want to get this equal to 0. So you're going to subtract 42.2 from both sides of the equal sign. So 2Q squared plus Q minus 42.2 is going to be your answer. So you're going to want to try to do this problem probably on the graphing calculator. I'm going to go to my graphing calculator to use my poly simulator here. If you do not have a graphing calculator, you can find one online. You can also come see me in class and I can help you get through this problem right here. But I'm going to show you really quick. I'm going to pull up my graphing calculator and work this, show you what I would do to get this. Okay, so I am going to go straight to my apps, and I'm going to use this poly simulator. It should be 9 on your calculator, so I'm going to go down there, pick 9, hit enter. I do want it to do this number 1, so I'm going to hit enter again. Then I want to hit next after I know this is on a 2, but next would be my graph button. Okay, so my equation was 2x squared plus 1x minus 42.2. Okay, and when we look at that, just want to make sure that was what I had. Yeah, minus 42.2. Okay, so we can get it to solve for us if we hit graph, and I want to ignore this negative because I know that that one's not right. So I'm going to go back to my paper and write down the 4.35 that's in the x1 place. So I'm going to come back to my document, 4.35. Okay, and so I found out that Q is equal to 4.35. Now, this measurement that I have ends up being different than what we have pounds per square inch here. So pounds per square inch, it says where Q is the flow rate in hundreds of gallons per minute. So this would be my hundreds of gallons per minute. So what is the flow rate? If the pressure loss is 42.2, what is the flow rate in hundreds of gallons per minute? they're wanting you to change it to gallons per minute, so we're going to need to take this and multiply it times 100. So that's going to be 435, and this is going to be, the units would be gallons per minute. Okay, if you need any help with the graphing calculator stuff, feel free to come talk to me, and we can work out the rest of that. Okay, so let's look at these last couple, 13, 14, and 15. They're pretty easy. It says, which category represents the largest expenditure? Well, it looks like your blue tuition category is the biggest chunk. Which category represents the smallest? It would be this 9% lab fee. It would be the smallest part of my circle up here. The students spent a total of $2,500, so the combined amount that went towards tools and lab fees was. So what do we know about this? We know if the total amount, and this is not the only way to work this, but if the total amount is $2,500, that would be 100%. So what did they spend towards tools and lab fees? Well, if we go up here and we look at lab fees, that's supposed to be 9%, and tools says 26%. So 9 and 26 is going to give me 35%. So we want to know, what is 35%? So we would cross multiply. Okay, so 2,500 times 35 is equal to 100 times x. 2,500 times 35 is going to get you 87,500 is equal to 100 times x. We would divide by 100, and we would get $875 for our tools and labs. If a student spent $300 on materials, materials is supposed to be, if you look up here, 10%. So materials is equal to 10%. Then the amount spent on books and lab materials, well, books and labs manuals is 17%. So we could work this the same way. So 10x is equal to 300 times 17. And that, it gives you 5,100. Then we're going to divide both sides by 10, and so x is $510 that they would end up spending on books and lab manuals if they spent $300 on materials. Okay. A table of values showing the number of community colleges in various regions of the country is shown to the right. On this one, they're wanting you to draw a bar graph, and it's going to be multiple choice, so I'm not going to be real specific about this, but you're making a bar graph here, and we've got at the bottom your A, B, C, D, E, F. You've got a table, so you're going 0, 10, 20, so these numbers in here would be your 5 and your 15. So A would go up to almost 9, but not there. B is 19, so almost all the way up to 20. C goes to 8. D goes right at 10. And so that's how you would carry on with this one, 15 and 4. You would finish those bars. That one's pretty straightforward. This one is very similar as well. So what you're wanting to do is this one's going to be a double bar graph. Okay, and so at the bottom of this, you would have you're going to have like 2003, so they just put 03, you'd have 04, 05, and you'd have some kind of a legend that told you what colors represented what things. So maybe they said this is the cost of regular gas, and maybe so let's just do those while we've got this out. So regular gas in 2003, let's say 1, 2, 3, it's 142. Regular gas is 142, so about halfway in between. And 2004 is 193, almost close, getting close to 2. In 2005, it is $2.32, so it's going up. So kind of in the middle, a little bit below the middle, 232. Then we could also, they're probably going to pick another color for your diesel. Well, in 2003, our diesel is actually just a little bit, right? Just a little bit below. In 2004, our diesel is 222, so it's a little bit above. In 2003, it's 270, so once again, and I probably made that too close to 3, but a little bit above. So you want to compare these and pick the right multiple choice out of which one's correct.